Hi, my name is Zach Harris, and in this video I'll be going over another problem of converting a closed form function into the recursive form for CSC 226 Discrete Mathematics for Computer Scientists. So in this problem we're looking at given f of n is equal to n cubed minus 4n squared plus 5, we need to find the recursive form. So just like the last problem we went through, what we're going to start with is we're going to start by getting the case before f of n, so f of n minus 1. So if we go ahead and plug that in, we end up with this right here. So from here, we want to find the value to transition from this function here, so the previous step, to the current step. So we'll get that once again through using subtraction right here. So if we subtract f of n minus 1 from f of n, we end up with n cubed minus 4n squared plus 5 minus n minus 1 cubed minus 4n minus 1 squared plus 5. So let's go ahead and start simplifying this. So the first thing we want to do is distribute out this minus sign here. So that'll turn this into a minus 5, which will allow us to cancel it here. So we can go ahead and make a simplification there. But outside of that, we're going to need to start expanding out these portions here. So when we do that, we end up with n cubed minus 4n squared minus n cubed minus 3n squared plus 3n minus 1 plus 4n squared minus 2n plus 1. So we'll go ahead and distribute out this minus sign here and take everything out of the parentheses and distribute out this 4 as well. So we end up with n cubed minus 4n squared minus n cubed plus 3n squared minus 3n plus 1 plus 4n squared minus 8n plus 4. So we can go ahead and cancel out a couple of these terms. So this will cancel out with this. This will cancel out with this. And from there we can just reduce down what's left. So we end up with 3n squared minus 11n plus 5. So from here, to get the recursive form, all we need to do is add back in the previous case to this side. So we end up with f of n is equal to f of n minus 1 plus 3n squared minus 11n plus 5. And we'll still need a base case for this since it is recursive. So for that base case, we're going to use f of 0, and we'll substitute that into the given equation. Which simply becomes 5 for our base case. So that'll be everything for this video. I hope you found it helpful. This is a little bit more arithmetic and algebra heavy than the previous example, but it does still follow the same concepts despite the initial formula looking a little different. All right, that'll be it for this one, and I will see you in the next video.